Have you ever wondered how a design once rejected by the military, deemed a miserable failure, could rise from the ashes to become the prototype for the entire modern tactical weapons industry? In the minds of mid-20th century soldiers, a true rifle had to be forged from heavy steel and polished walnut. They carried bulky, heavy M1 Garands and M14s, bearing the heavy imprint of two world wars. But in a small corner of the Armalite machine shop in California in the mid-1950s, an aeronautical engineer named Eugene Stoner viewed weapons through a completely different lens. He didn't see wood and steel. He saw aerospace-grade aluminum, fiberglass, and synthetic polymers. He saw the future. And from that vision ahead of its time, a mechanical monster was conceived. The AR-10 rifle, known to the world by its legendary name, the AR-10. Our story begins not on the battlefield, but within the molecular structure of the materials. Imagine solid blocks of 7075 T6 aluminum alloy, a material typically reserved for the airframes of supersonic fighter jets. They are light, flexible, yet possess an astonishing tensile strength. In a modern machining shop, the deafening roar of a multi-axis CNC mill shatters the silence. A carbide drill bit, spinning at tens of thousands of revolutions per minute, bites violently into the silver aluminum block. Milky white coolant sprays out under extreme pressure, sizzling as it washes away the bright, curled aluminum shavings flying in all directions. The machine carves the lifeless block of metal, shaping the upper receiver and lower receiver of the AR-10. Eugene Stoner's courage lay right here. He dared to discard traditional forged steel to encase this killing machine in a feather-light aluminum shell. But aluminum is just the shell. The heart of the AR-10 is a masterpiece of aerodynamics and precision engineering, the direct impingement system. Let's dive deep inside the chamber with a microscopic camera to witness the magic of physics. Unlike rifles that use heavy, clunky gas pistons, the AR-10 possesses a bolt carrier group machined from a solid block of reinforced alloy steel. At its head sits a bolt featuring 7 locking lugs arranged in a star pattern, along with an integrated extractor. As this bolt carrier group slides forward, these 7 steel lugs slip through corresponding slots in the barrel extension, then rotate slightly to lock the bullet dead into the firing chamber. This locking mechanism turns the chamber into an impenetrable vault, ready to withstand the most horrifying pressures. And here it is, the 7.62 x51 mm NATO round, also known as the 308 Winchester. This is not the tiny 5.56 mm round of its later younger brother, the AR-15. This is a mass of brass and lead weighing up to 175 grains, packed with a highly potent, slow-burning, extruded powder. The primal power of the infantry. Hold your breath. Pull the trigger. The hammer is released from the sear, striking the firing pin with immense force. The steel firing pin lunges forward, slamming into the primer at the base of the gleaming brass casing. A tiny spark erupts, igniting tens of grains of propellant. In a 10,000th of a second, the powder converts from a solid to a gas, creating a colossal pressure that fills the chamber. With nowhere else to go, this violent surge of gas forces the heavy projectile forward, violently gripping the rifling grooves inside the steel barrel, initiating a spin of hundreds of thousands of RPMs to stabilize its trajectory. But the true magic of the AR-10's gas system lies right here. As the bullet passes a tiny hole tapped into the barrel, a portion of this high-pressure gas, burning at thousands of degrees, is siphoned off. It rushes backward through a tiny stainless steel gas tube, as thin as a chopstick. This gas blows directly inside the bolt carrier, acting like a giant hydraulic cylinder. The hot gas forces the bolt carrier backward. This rearward motion forces a cam pin to travel along an angled path, compelling the bolt to rotate and unlock its 7 lugs. The moment it unlocks, the extractor severely grips the rim of the scorching hot brass casing, violently pulling it from the chamber and ejecting it outward through the ejection port in a beautiful arc. The buffer spring inside the stock is compressed to its absolute limit, absorbing the recoil, then instantly snaps back, driving the entire bolt carrier group forward, stripping a fresh round from the magazine and driving it into the chamber. This entire chain reaction of physics, thermodynamics, and precision engineering occurs smoothly and flawlessly in the blink of an eye. However, history doesn't always lay out a bed of roses for geniuses. The AR-10 carried within it the tragedy of being ahead of its time. In 1956, when the military was searching for a new rifle during the grueling trials at Springfield Armory, Eugene Stoner brought the AR-10 to compete. To push the weapon's weight down to the absolute minimum, Armalite's president at the time forced Stoner to use an aluminum barrel sleeved in titanium and fiberglass instead of solid steel. It was a fatal decision. Amidst the hail of gunfire during the torture tests, under the terrifying pressure and heat of the 7.62 millimeters round, the AR-10's composite barrel failed. It cracked and ruptured. A deafening explosion rang out, tearing the fiberglass shell apart and taking the entire project down with it. The U.S. military shook its head and turned away, selecting the traditional wood and steel M14. The AR-10 was shunned, sinking into oblivion, a masterpiece discarded, all because of a managerial error in materials. But the laws of physics never lie, and a perfect design never truly dies. From the ashes of the AR-10, Eugene Stoner downsized it, changed the caliber, used a standard steel barrel, and created the AR-15, which later became the U.S. military's legendary M16. The AR-10 stepped back, quietly yielding the spotlight to its younger sibling, becoming a progenitor hidden in the shadows. Decades passed, the battlefield changed. Urban warfare and mountainous terrain demanded a superior weapon. Soldiers needed a rifle with the accuracy of a bolt-action sniper, yet possessing the semi-automatic fire rate and rapid reload capability of an assault rifle. The 5.56 millimeters round of the M16 AR-15 lacked the penetrative power at long ranges, and so the world called upon the progenitor once more. The AR-10 awoke from its long hibernation. The resurrection of the AR-10 inches the modern era is a symphony of cutting-edge materials. It is no longer the rifle with the original red plastic handguards of 1956. Armament companies like Knight's Armament Company took Stoner's blueprints and evolved them into the SR-25 system, one of the most fearsome, designated marksman rifles in the world. Look at its transformation. The barrel is now crafted from 416 R-match grade stainless steel, computer drilled and turned to achieve perfect tolerances down to the micrometer, ensuring the bullet's trajectory does not deviate by a single millimeter at distances of thousands of meters. The surface is coated in Cerakote ceramic, offering wear resistance, heat tolerance, and infrared stealth. The handguard system now consists of aerospace aluminum M-lock rails enveloping the barrel without ever touching it, a free-floating barrel. This free-floated design ensures the rifle is unaffected by the pressure of the shooter's hand, maximizing the vibrational accuracy of the steel barrel as the bullet exits. Instead of the primitive iron sights housed in the carrying handle of its early days, the modern AR-10 is equipped with massive, multi-coated optical scopes capable of piercing the night using thermal imaging technology. At the muzzle, a heavy-duty suppressor is locked on via a quick detach system. Not only does it extinguish the blinding muzzle flash, but it also reduces gas pressure, compressing the space-tearing sonic boom of the 7.62 millimeters round into a deadly thwump, concealing the sniper's location in the dead of night. The light, flexible rifle of 1956 has now evolved into a cold, precise, and brutal heavy-duty demolition machine. To truly understand the power of this progenitor, let us step out onto a sniper proving ground in the middle of a barren desert. Blinding sunlight beats down on the golden sand, while scorching air rises, creating twisting mirages. At a distance of 1,000 yards, over 900 meters, a tiny steel target the size of a human torso stands alone. A sniper in camouflage lies prone on the earth, the hydraulic bipod of the AR-10 gripping tightly to the gravel. The Desert 10 rifle blends seamlessly into its surroundings. The shooter pulls the charging handle. Clack! The heavy 308 Winchester round rests obediently in the chamber. Through the 25x magnification optical scope, he calculates windage, humidity, barometric pressure, and even the rotation of the Earth itself, the Coriolis effect. Every law of physics is gathered at the tip of his index finger, resting on the trigger. His heart rate slows. Inhale, half exhale, hold. Squeeze the trigger. A sharp, muffled thwump crack rings out through the suppressor, but the resulting shockwave is still powerful enough to kick up the sand beneath the rifle's belly into a blinding cloud. The bolt carrier violently kicks backward with absolute mechanical force, ejecting the scorching hot brass casing into the air as thin wisps of smoke escape from the ejection port. Simultaneously, the 7.62 millimeters bullet, traveling at nearly 800 meters per second, tears through the heat haze, tracing a perfect ballistic arc across the desert sky. Air resistance tries to drag it down, but immense kinetic energy continues to drive the mass of lead and copper forward. 1 second, 2 seconds. Time seems to stand still. And then, ping! A resounding metallic ring echoes back from 1,000 yards away. The bullet has driven dead center into the steel target. Piercing through twisting mirages and defying the drag of the wind, the mechanical accuracy of the AR-10 has conquered an impossible distance. The shooter does not need to take his eye off the scope. His finger remains on the trigger. The direct impingement system has already automatically chambered the second round in a fraction of a second. He is ready for the next shot. There is no delay of a manual bolt-action reload. There is only continuous, cold, and absolutely precise destruction. From a blueprint shunned by the military in the 50s, overcoming a fateful barrel-bursting incident, yielding the limelight to its younger sibling, the AR-15, only to rise decades later as one of the most fearsome and versatile infantry weapon platforms on the planet. This is the life cycle of the AR-10. It is not just a rifle. It is the embodiment of shattered conservatism, modern metallurgy, aerodynamics, and the human aspiration for engineering perfection. Eugene Stoner may have departed this world, but the legacy he left behind, the silhouette of that aerospace aluminum block and that direct impingement system, continues to roar, continuing to reshape the face of every battlefield in the 21st century. The screen gradually fades to black, the sound of the desert wind howling through empty brass casings. Silence, closing a chronicle of steel and fire.